We'll be seeing how to calculate percent accuracy from a short speech sample. Here we'll be using productions from the Goldman-Fristow test of articulation 2. We're not going to be scoring this, we're just going to be using the productions as a small sample. To calculate accuracy, you need to know what the target production would be, because this is a relational measure, not an independent measure. So it's directly comparing what is produced against what would be the correct form. Now, if you're looking at a data set or you're working with your own data and you don't have these targets, it's probably best to write them in somewhere. And so I'm going to do that here. So one important thing when calculating accuracy is that you start by looking at the target production. That's easier than looking at the actual, because we organize the results by the target. So starting here, we have target S produced as an F by the child. That is not a correct production, so we get one attempt, but we do not put a tally under correct. Now moving on, we're not looking at T, but we are looking at R. So we're going to add an attempt here because there's an instance of it in the target, but it was not produced, so we do not add again in the correct column. We're not looking at W, we are not looking at N, but we are looking at D. So there was one instance in the target, that's an attempt, and the child actually produced the sound correctly. So they get a tally in the correct column. We're not looking at T, we are looking at L. So that's an attempt for L. It was produced as a tap. That is not correct, so we don't add one to the correct column. F, but that's also not a correct production because they produced it as P. And we're not looking at that. No T, no P. Here we have another F, this time produced as S. So for target F, that was an attempt, but it was not produced correctly. Now here, I'd like to highlight this situation here, which is pretty interesting and really highlights the difference between a relational accuracy measure and an independent type of measure. So this child produces an F here where there should be an S, and they produce an S where there should be an F. Now if we were doing something like a phonetic inventory, we'd be counting and giving the child credit for every production they make, regardless of what the target is. So the child would get credit for producing an F here, get credit for producing an S here. In a relational accuracy analysis, we do care whether the actual production matches the target. That's why this child's performance in this relational accuracy measure is lower in some ways than it would be in an independent measure that gave the child credit for these S and F productions regardless of the target or independent of the target. Although the child does use F and S, so far they're at 0% accuracy because they're not used in the right place. To complete this activity, you would continue through the rest of the data set, tallying every occurrence of each of these targets in the target words in the number of attempts column, and then only include a tally in the correct column if the child actually produced the target sound in the correct place. Now you might be wondering, how does an accuracy calculation like this relate to a more formalized type of accuracy calculation like percentage of consonants correct? So if you're using a single word sample, like data from the Goldman-Fristow or some other informal probe, you would use percentage of consonants correct revised, which was intended to be used with a single word type of sample. There are several differences between the original percentage of consonants correct and the revised version. Some of the most important ones are that the original PCC was developed for use in connected speech samples, and distortions were considered to be incorrect. The revised version is intended for use with single word samples and permits distortions productions as correct productions. So, summarized, what differentiates percentage of consonants correct from this more informal type of accuracy measure is that percentage of consonants correct, or PCC, involves all the consonants, whereas accuracy can be calculated for individual consonants, only a subset of consonants that you want to look at, or even larger components like consonant clusters. And percentage of consonants correct, because it is a criterion referenced measure, has specifications for what counts as a correct instance and what doesn't, whereas your own informal accuracy measure is subject to your own interpretation of what accurate means. Some of the rules for percentage of consonants correct are displayed here if you would like to note some of the specifications for this measure.